All right, this is section 7.2 notes, finding cube roots. A cube root of a number is a number that when multiplied by itself and then multiplied by itself again equals the given number. I'll give you examples here in a second. A perfect cube is a number that can be written as the cube of an integer. So it's an integer times an integer times an integer. The symbol for cube roots, this is important. It's the same radical sign, but there is a 3 in between the radical and that top bar. Make sure you are not, it is not this. It is not 3 that. Make sure that the 3 is right in between the radical sign and the other bar. This would not be correct. So here's some examples. Find each cube root. Okay, there is a way to do this on the calculator, but you also need to know how to do it using your brain. Okay, so the cube root of 8, I need to think of 3 numbers when the same number multiplied by 3 times gives me 8. Okay, so the cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. 2 times 2 is 4. 4 times 2 is 8. Okay, negative 27, I need to think of one number when multiplied by itself and by itself again gives me negative 27. Now this negative here I got to pay attention to. So negative 3 times negative 3 times negative 3 gives me a negative 27, because negative 3 times negative 3, this gives me 9, and 9 times negative 3 gives me negative 27. So the cube root of negative 27 is negative 3. I'm going to show you how to do these on your calculator here in a second. Hang with me. Part C, just like with square roots, you can split these up. So this would be the cube root of 1 over the cube root of 64. So the cube root of 64 is 4, and the cube root of 1 is 1. So the answer to part C would be 1/4. Now I'm going to pause it and try to get the calculator on my screen so you can see what I'm doing and how to find cube roots on your calculator. Okay, I'm going to show you both calculators how you do it. If you have the TI 30X 2S or the TI 30XA, these are the ones that are in my classroom, and these are the ones you should have gotten at home. Okay, so to find the cube root of 8 on this pink one, you're going to hit 3, and then you're going to go second, and the button is this arrow guy right here, and it should give you an X with the radical sign. That X is standing for the 3. So this means the cube root of 8, and then you hit enter, and you should get 2. Okay? Same thing if I'm finding the cube root of 27, hit enter, and you get 3. If I'm finding the cube root of 64, it's 4. Okay? So pretty simple on that one. This one's a little bit more challenging, which is why I prefer you have these calculators. For this one, you need to do, if I'm trying to find the cube root of 8, I do 8, and then second, and then the same symbol, this yellow symbol, is on the y to the x button, okay? And then you hit y to the x, and then you hit 3 for the cube root, and it should give you 2. If I want the cube root of 64, I hit 64, second, xy button, and 3, and you get the cube root of 64 is 4, okay? So once again, I really prefer you have these pink calculators. If you don't have one, if you can pick one up, they're about $12. It would be very, very, very helpful. All right, now I'm switching back to the notes. All right, just like with square roots, cubing a number, so x cubed is the inverse. The inverse operation would be finding the cube root of x. Okay, so just know if you have x cubed and you're trying to solve for x, you have to take the cube root of both sides. All right, here is example 2, evaluating expressions involving cube roots. So the first thing you always do is evaluate the root. Okay, so this is the cube root of negative 216. If I put that in my calculator, the cube root of negative 216, you type it in exactly like you see it as negative 6. So this would be 2 times negative 6 minus 3. Order of operations, I do this first, so I have negative 12 minus 3. And my integer rules, I have negative 15 as my answer. Part B, you do the cube root of 125 first. This would be one that I would think you could have memorized, and that is 5. 5 times 5 times 5 is 125. So then you need to do 5 cubed plus 21. So you're basically undoing that. So that's 125 plus 21, and that gives you 146 as your answer. All right, these are on your own. Pause this, try them on your own, hit play when you're ready, and see if you are getting the correct answer. All right, cube root of 1. 1 times 1 times 1 is 1, so the answer to this one would be 1. The cube root of negative 343, that would be one I'd put in my calculator. And you get negative 7. So negative 7 times negative 7 times negative 7. So my cube root is negative 7. And this one you need to split up again. So this would be the cube root of 27 over the cube root of 1,000. This would be one I would expect you to have memorized. The cube root of 27 is 3. The cube root of 1,000, this is another one I think you should be able to do, is 10. Okay, 10 times 10 times 10 is 1,000. So the answer to number 3 should be 3/10. I think this one you could do without a calculator, and number 1 you should be able to do without a calculator. Oh, you have 3 more. Okay, try these again on your own and pause it when you're ready. Okay, do the cube root of 8 first, and that's 2. So I have 18 minus 4 times 2. Then I do my multiplication, 18 minus 8, which gives me 10. The cube root of negative 64 is negative 4. And then you have to cube that plus 43. Negative 4 cubed is negative 64 plus 43. And that is negative 21. Okay, when you see the cube root and then it's cubed, you know those are both going to cancel each other out, and you're going to get the number that's under the radical sign, which remember is called the radicand. The cube root of 512, that one I do not have memorized, so you can use your calculator on this one. The cube root of 512 is 8, so you have 5 times 8 minus 19. So this is 40 minus 19, which gives me 21. Okay, hopefully those are getting a little bit easier. And here is example 3, evaluating algebraic expressions. So I need to plug 192 in for both of these x's. Okay, so if I'm rewriting this, I have 192 over 4 plus the cube root of 192 over 3. Okay, so I'm going to divide 192 by 4, and this gives me a pretty number. So let me change the colors here. So this, if I divide it in my calculator, I get 48, plus, I'm going to divide 192 by 3, and this gives me 64. So I want the cube root of 64. Now the reason I didn't split these is because I know there's no cube root of 3 that's a perfect number. So then I chose to divide them and see if that worked for me better, and it did. So the cube root of 64 is 4, so I have 48 plus 4, which gives me 52 as my final answer. These are pretty easy if you remember to plug them in and evaluate. All right, try 7 and 8 on your own. Press play when you're ready, and we'll see if we get the same answer. All right, plug 64 in for both these. Why? I highly recommend you rewriting the problem. Okay, because if you're not rewriting it, you're going to mess something up. Okay, so 8 times 64 is 512. So this is the cube root of 512 plus 64. The cube root of 512, I feel like I just did that. I did, is 8. And 8 plus 64 is 72. In question 8, plug negative 3 in for b. In both of these, rewrite the problem so that you don't mess something up. So this is negative 6 minus the cube root of negative 27. And this is one you should have memorized. So this should be negative 6 minus the cube root of negative 27 is negative 3. That looks like a 1. In integer rules here, this is really negative 6 plus 3, which gives you negative 3 as your answer. Example 4 is our real-life application. So I need to find the surface area of the baseball display case. Okay, so our hints are volume equals side cubed and surface area. And I messed up, so I'm rewinding. You might wonder why I included the volume equation in there. And that's because I need to find the length of the side before I can find the surface area. Okay, so I'm going to start with volume first. and volume equals side cubed, and I know the volume is 125 equals side cubed. So if I take the cube root, don't forget the 3, if I take the cube root of both sides, my side is equal to 5. Okay, now that I know the sides are equal to 5, this is 5, this is 5, and this is 5, now I can find the surface area. So surface area is equal to 6s squared, which is equal to 6 times s squared, which is 5 squared is 25. 6 times 25 is 150. I need units. 150 inches. And surface area is inches squared. Volume is cubed. Surface area is inches squared. Okay, so that is the answer to example 4. Okay, last one. The volume of a music box that is shaped like a cube, so it's very similar to that picture. The way I normally draw these is you make a box, and then make a box down here, and then you have to connect the dots, and good thing I'm not an art teacher, right? So the volume of this box is 512 centimeters cubed, also known as cubic centimeters, and I need to find the surface area. So the same thing, I first need to find the side lengths, so I need to say that volume equals side cubed, and 512 equals side cubed. Okay, if you take the cube root of both of these sides, the cube root of 512 is 8. So each side length is equal to 8, and that's centimeters. So then to find surface area, that's 6s squared. So it's 6 times, that's equals 6 times 8 squared. 8 squared is 64 times 6 is my surface area. And calculator, 6 times 64, I'm probably doing this faster than I am, is 384. So the surface area is 384 centimeters squared. And I think that's it. Sorry, it's a little bit longer, but I hope it all makes sense. Come tomorrow with questions.